Okay, let's see if we can do this video. I won't say that I'm the most professional for this, but we'll try to keep notes of everything that we're doing. Okay, so this is for the central limit theorem for Math 115. We're going to start with question number 1. Okay, so Uni is a personal manager in a large corporation. Each month she must review 16 of the employees. So that's the total count. So there's 16 employees. From past experience, she has found that the reviews take her approximately 4 hours each to do with a population standard deviation of 1.2 hours. Let x be the random variable representing the time it takes her to complete one review. Assume x is normally distributed. Let x, I think that's x with the bar, the sample, be the random variable representing the mean time to complete the 16 reviews. Assume that the 16 reviews represent a random set of reviews. Okay, so we had to fill this in. We know that this is a normal distribution. I think it said something right here. Let's assume x is normally distributed. So when we choose these, we know it's going to be a normal, not uniform, right? And so if it's normal, we're going to find the mean. What is the mean? And it says that the reviews take her approximately 4 hours each, which that would make the 4 the mean. Okay, so I'm just going to put some notes up here. We're going to say out of this, we know that the mu is 4 hours. And we know that the count is 16 people. And we know that the standard deviation according to that is 1.2 hours. Okay, so that's some of the information that we know. Okay, now for this one, for the sample, right, we're using this one here. How would that be normally distributed? Okay, so what would mx be? Mx. We know that that's exactly the same. That doesn't change. So we know that's 4 hours. But the standard deviation sample is going to be different. And to do that, we have to get the formula, which is, we're going to take the standard deviation, we're going to over the square root of the number, of the count. Right, so in this case, if we were to take those numbers, we take that standard deviation 1.2. Okay, again, I want to show that. I don't think ours is different, so standard deviation of 1.2 hours. Okay, so we'll put 1.2 on top and over the square root of the count, which is 16, because there's 16 employees. And then I just do things step by step like that. Okay, because the square root of 16 would be 4, and then we divide 1.2 by 4, and we're gonna get 0.3. Okay, so in other words, the standard deviation sample is 0.3. Okay, so when we fill that in, we've got the mx is 4, and we've got the mx, which is the mean sample, and the standard deviation sample is 0.3. Okay, let's move on. It's the same exact question, so I'm not going to read it, but this is number 2. But then we go on to find the probability that the mean of a month's review will take uni from 3.5 to 4.25. Okay. And here we got, it's the only one that goes from 4.25 and 3.5, so that's why this one makes sense. The probability is going to be 3.5 to 4.25. And how do we figure this out, you know? Let's see. this one, let me move this. Okay, that is the probability, because it said what is the probability, right, that the mean of a month's review will take uni from 3.5 to 4.25. Okay, so when you see that X, that sample right in the middle, the formula goes like that, right? Oh, probability, sorry, 3.5, we've got X to 4.25. Okay, so looking how we got this. Okay, so we're gonna take the first part. We're gonna take z equals 3.5 minus 4. Sorry, let me first start by showing you the formula. This is confusing, isn't it? Okay, this is going to be the formula. Okay, for us to get the z, it's going to go this, x minus mx over the standard deviation sample. Okay, so first we're going to go with the number that we're choosing, which is 3.5, minus the mx, which we know is 4, okay, over the standard deviation, which we know is 0.3. Okay, let's bring that down. So we've got negative 0.5 over 0.3. Bring that into some, that becomes 1.666, or you could say, if we rounded it, 1.67. Okay, so then when you go to your z table with 1.67, we're going to do that after, but let me do the second one. Okay, so that was this, we'll say this is z1, and that's what it comes out to. So let's go with z2, which is the high end, which is 4.25 minus 4, again over the standard deviation, 0.3, so we got 0.25 over 0.3, which will become 0.83. Okay, so then, don't know any easy way to do this. Let's go math. Let's go to my formulas. Let's go to the z table. All right, so we're looking at this one, right? For the 3.5, we need to find the 1.67. So we go down in our z table and we find, oh, I'm sorry, I forgot the negative. This is a negative. So this is a negative. So it's negative 1.67. Sorry. My pen's not working. Okay. Okay, negative 1.67. Negative 1.6. We have to round it to 2 numbers because this z table only works with 2 numbers. So 0.0475. Okay, so we got 0.0475 for the z from the z table for that 0.83 point, so that z-score of 0.83 becomes 0.7967. 0.7967. Okay, and then the last step, oh, moving my things all over the place. The last step is to take z1 minus, oh sorry, z2 minus z1. So we've got 0.7967 minus 0.0475 equals 0.7492, and I think the answer that they wanted was, you could put 4 decimals. I only put 2. I rounded it to the 2 decimals, which would be 0.75. I suppose you could put all 4, but I didn't. Okay, hopefully that all makes sense. That was just for one problem for number 2. Okay, so let's move on to number 3. Okay, so number 3, I didn't get the second part. I have to ask him about percentiles. Again, it's the same exact question, but it says find the 95th percentile for the mean time to complete 1 month's review. And for me, the only one that made sense was that when it hits the 95%, everything to the left is going to be shaded in. So that's why I chose this one. And I have yet to figure out how to do the percentile. So we'll move on from there. Okay, so number 4. A researcher measures the amount of sugar in several cans of the same soda. The mean is 39.01 with a standard deviation of 0.5. The researcher randomly selects a sample of 100. Okay, let me just say that this is where things are going to get really complicated, but let's take some notes to the things that we do know. Okay, so we know that the mean is 39.01. Let's just start with the things that we do know. The mean is 39.01. We know that the standard deviation is 0.5. So the standard deviation is 0.5. And we know the count says that they randomly select a sample of 100. So we know that the count is 100. Okay, this is where it gets really complicated. It says find the sum with a z-score of negative 2.4 for me. So let's write that the z is 2.4. Whatever yours is, that's what's going to be changing. But here's the formula, because here's the formula for the sum. Ex, this is the sum of, right, of x. Ex, we've got the count times the mean equal, the z-score times the count, the square root of the count, times the standard deviation. Now, that's the standard deviation, not the standard deviation's mean, right? Or the sample standard deviation doesn't have the bar over it, so that's just a normal standard deviation. Okay, so we know that mx is the same, the mean of the sample is the same as the sample. We know that the standard deviation sample is the same as standard deviation. Now, if it said this with the bar over it, this would be the same. as the mean. But this is where you would have to do that formula where we did the standard deviation over the square root of the count, right? That's different. But we don't need that in this case. So let's start filling in our information. What's the count? The count is 100. Oh man, that's not good. Same pen too. And I grabbed it again. Okay, let me get a different pen. Filling in our information, we've got the count, 100, times the mean, 39.01, plus the z-score, which is 2.4, plus the square root of the count, which is 100, plus, sorry, this is multiplying, times the standard deviation, which is 0.5. Okay, so let's do these. This comes down to 3,901 plus, let's just bring these down still, because I'm just a step-by-step kind of a person. Okay, what's the square root of 100, which is 10, 0.5. Okay, so let's bring all of that down, times all of these together, and you've got negative 12. Let's bring this down. And so we've got a total of 3,889. That is the sum of the count of all of this. Okay, hope you